Hi, folks who are coming in. Welcome to the computer science breakout session here. I will get started in just a few minutes as I see the attendees are starting to come in from the previous session. So give everyone a few minutes while I introduce myself. My name is Matt Alexander. I'm the current acting director and associate dean for computer science. And with me is Joyce Dahlhauser, who is one of our program mentor managers for computer science.
Hi, everybody, and welcome.
Wonderful. So we will get started in just maybe another 30, 40 seconds as I still see people are coming in here. You'll be able to use the chat or the Q&A area to communicate with us. So if you have questions that are, Q&A style questions, throw them in the Q&A. If I've just been talking into the void and you can't actually hear my audio, hopefully you'll somehow find that chat section and tell me that nobody can hear me. Hi, Daniel. All right, I see people able to find the chat, so very good. All right, well, now I'm going to try to share audio on a screen here. All right, and we'll back it up.
It's time for us to talk about computer science. You might be thinking it's all about the 4K i9 32GB super laptop that computer scientists probably make. Well, yes, but really, no. Let me break it down. So we have a laptop, the usual stuff, the hard drive, the screen, the processor, the design, and the person who deals with this all is the computer engineer. They're the ones who create the device. Okay, so what about the software then? You know, Microsoft Office, Photoshop, Google Chrome, and the operating system, of course. Meet the computer programmers and the software engineers. Hold on. Isn't this video on computer science? So where do they fit into this? Time to dig a little deeper. Say you're on the computer surfing the web and wanted to find out what song was currently #1. You have 4 websites to choose from. How would you decide which one to choose? Obviously, it's the most popular one, right? But what if they were all as popular as each other? What if they all had very similar content? How would you know which one is best? Well, a couple of guys spent some time working on this and managed to create an algorithm to figure that out for you. It's called Google. Yes, Google. And this is what computer scientists do. They're the ones making the magic happen, really making our lives easier. But the engineers, the programmers, the scientists, they all work together to deliver those beautiful phones and computers packed with incredible software so we can do what we do. So back to algorithms. Think about when you're traveling to work in the morning. How do you know what the best route is? You would need to figure out where everyone is and where they're going. Then and only then do you know what the best route is. And guess who writes the algorithms to work that out? And these algorithms are everywhere, from connecting computers together through AI and improving the way we communicate with robots. If you can't think of the last time you did this, think about Siri, Hey Google, and Alexa. Meet the Internet of Things, aka IoT. Like when you say, Hey Alexa, turn the lights off at home. And if that wasn't enough, what about those smartwatches that can detect if you've fallen over? Yes, algorithms strike again. And you know those computer engineers, software engineers, and programmers? They all play a massive part in this too. It's like one big family. Imagine you had a drugs trial involving thousands of cancer patients. You've nailed the algorithms to make sense of it all. But what about storing this data? It's very sensitive and needs to be safe from criminals. And this is where maths is involved. But not the maths you're thinking about. You know, where you have to figure out what X is. Welcome to the world of prime numbers, the fundamentals in encrypting data. You see, it's pretty easy to take 2 very large prime numbers and multiply them together. But just imagine if you had to do the opposite. Say you were given a very, very large number, and you have to find out the only 2 prime numbers that make up this number. Seriously, where would you even start? Now, we can't do this very fast, but computers can. But even then, they are limited by their power to how fast they can compute. And this is exactly what encryption is based on. The bigger the numbers, the more secure the data. So yeah, good luck to those guys trying to crack our WhatsApp messages. There are some great videos on YouTube that explain this. Links are in the description. Really, there is no limit to what we can do with computer science. You could be creating platforms where you can meet new people, like Facebook. And if that wasn't enough, what about ways of reducing our carbon footprint? Not by re-engineering the engine, no, but by rerouting traffic, yes. And guess what? Remember the engineers and programmers I mentioned? I forgot to say, this industry is very tightly knitted. You could be designing hardware as a computer scientist or even writing programs. You just need to know the core elements. Oh, and knowing a language like Java or C++ is always a benefit. With that, you could pretty much go into anything. The world is your oyster. If you like this video, leave a comment, give us a thumbs up, subscribe. And if not, you know what to do. Oh, and if you really like this video, head over to Patreon where you can show your support.
All right. So hopefully that video gives us a ground level view of, or I guess a high level view of what computer scientists are about and what the goal of any computer science program is. I did see some people are students who are incoming. Welcome to the program. Hopefully we'll be able to answer some of the questions you might have. I know some of you are prospective and some of you are looking at different options. So hopefully we'll be able to get some of those questions answered. And again, there's a Q&A section as well for like questions that you want towards the end. But I'll just go ahead and get into it here. So we did, this isn't, there we go. So we did the video on what is computer science, right? And really what we're looking at is a study of a bunch of different things. And I like to say that computer scientists are the generalists of the tech field with deep technical knowledge, right? So they're the ones who can be working and intersecting on problems across the vast domain of IT, right? And I see a question about AI on entry-level roles. Throw that into the Q&A. I'm certain we'll get to that one, but throw that in the Q&A section if you can, so that we can talk about that a little bit more at length at the end, right? The different types of problems that computer scientists encounter, right? So there's questions around abstract things like, well, can a computer even solve that? And then there's the actual, well, I know that this can be solved, but we need to be able to implement it to this particular field, right? We know that a solution exists, but we need to be able to make it make sense within the domain that we're working. So what are the thinking patterns, or how does a computer scientist think? And this doesn't have to be you 100% today. Part of the program is training you how to think in these ways, right? But generally speaking, those who are inclined towards math and programming and problem solving at scale, right? You want to make a positive impact, and you're able to work independently and with others, certainly not a field where you're just an individual working on a problem by yourself anymore. And then we apply scientific method approaches to trial and error, think about and reason over things very analytically, and have all those problem-solving skills in our toolkit, right? What does a computer scientist do? The video got into that a little bit, but really most anything, right? Computer scientists, again, are the generalists, but with deep technical knowledge in the field. So you'll find intersections in most fields of interest. And one of the things that I in particular love about computer science is how it intersects with so many different domain areas, right? If you're somebody who has a background and an interest in, for example, healthcare, there's bioinformatics and genomics. If you're somebody who is interested in mechanical, engineering type applications with robotics, you have an intersecting field, and so on and so forth, right? There are really many more intersections here. These are probably the ones with the biggest demand out there right now. What do you learn in a computer science program? Algorithms. Again, the video kind of got at that, right? One of the biggest things that you'll come to know is various known algorithms to solve known problems. And again, one of those areas where you apply your problem-solving abilities is to know how to apply solutions to new situations, right? So algorithms help us do that. And there's a few different fields where you'll learn some topics like the calculus, discrete mathematics, right? And the applications of those within cryptography, data science, simulation. We have course sequences on artificial intelligence. Of course, that is one of the big emerging areas right now. And there are many, many applications there. And I think we'll only see more as the field continues to develop. I want to say that this is nothing new. 10, 20, 30 years ago, there were applications of artificial intelligence. We're just getting to a point where we have these large models and the computation to run them, right? And then data structures and algorithms is one of the core topics within computer science. And that really influences not only how we move around and store and access data, but then also the ability to retrieve or to spread out that data over many different servers, right? Continuing on, some common misconceptions. I already got at a little bit. This is not a field where you work on your own at your computer and don't talk to anyone. It's very much a field where collaboration is expected and the norm. There are often dual career paths within most of the fields of interest, software engineering, and other research and applied roles, where you can go towards more management focused. But there are also individual contributor pathways in most larger companies now. You should know a few languages coming out of our program. You'll definitely have experience with Python, C++, and Java. So you'll have a core set of languages that you'll know, but then you will continue to branch out over time, depending on the needs for your future career growth and research interests, right? Job hopping, it comes and goes on whether or not it's the best path forward for people, but it is not something that you absolutely have to do. You can continue to advance in your career, especially if you are with a larger organization without having to job hop. And then, as I said earlier, computer scientists are generalists in some sense, but that doesn't mean that it's at a very basic level. It's at a deep technical level, right? Just because it covers a large number of topics doesn't mean that it's only a surface level for those topics. All right. Let's talk a little bit about our bachelor's program, and then we'll talk about the master's tracks for any of you who are in here for our master's programs. Included in all of our programs, the learning resources are included with tuition. You have course instructors available to meet one-on-one and in cohorts. You also have community resources of fellow students and your instructors. I need to change that. It's no longer Inscribe. It's another vendor that we use. But in either case, you have those resources because we know that online universities, you have to be more intentional with reaching out and making those connections, right? We also have 2 third-party certifications embedded in the program. That's the IDLE and LPI Linux Essentials certifications. Those are at no additional cost for your tuition. You take those as a summative exam at the end of your courses, just like any other course. We also have embedded micro-credentials to show some of the lines of skills that you're developing to potential employers, and that's in backend, AI, and Java. Textbooks. So many of our textbooks are interactive textbooks through, for example, Zybooks, which allows us to have multiple choice type questions as well as programming right within the textbook. And then in more advanced courses, you'll take those skills and move them into an IDE where you're doing larger projects, at scale. We do have 2 programs where people are often interested in one or the other, BSCS and BSW. So the focus in BSCS, as I've mentioned, is on algorithms and problem solving and these sort of computing type problems. There's also, if you're somebody who wants to focus on lower level systems and optimizations, that's absolutely BSCS. With BISWE, you're really going to be talking more about building products. You're going to take some of the same programming courses, for example, but the focus is more about being able to build software at scale for software engineering versus being able to build algorithms that scale in computer science, right? There's the clicky. Okay. And then BSCS versus BSIT. So I did mention BSCS generalists. BSIT are also generalists, but they're generalists with different technical skills and knowledge, right? So with BSCS, you're going to be going into more algorithmic and technical skills with solving things. BSIT is going to be more, again, how do you have IT organizations at scale? How do you work problems and systems at scale? More of the business focus on that end, right? We also have some new, and I'm going to have to take new off of that soon because we're 6 or so months on now. New graduate level programs. We have basically a core computer science program with 3 specializations, right? The goal of the core is to give you the foundational, not foundational because it's at a master's level, but the sort of timeless skills that computer scientists use. And then with the specialization tracks, you're looking to branch out and specialize and find the niche positions that are in your particular field of interest, right? So the 3 tracks that we have, advanced AI, that's certainly, again, just very popular right now, and we recognize that there's a lot of value. One of the things that I used to say frequently is follow where the venture capital money is going right now, and that is certainly all in AI. But those aren't the only positions that are going to be out there. Human-computer interaction, so talking about how people interact with computing systems, that has an important area and will come into play more and more as people continue to interact with computing systems more and more, and AI included in that. And then the core computing systems, which is by and large the generalist but with technical skills expansion of our computer science program, talking about networking, cloud, IoT, and more focus on the design implements, which I saw an article about some quotes from Bill Gates recently about why software engineering isn't necessarily going to go away, and I might be jumping to that Q&A question a little bit. But one of the elements there is that you're going to have to design for what you want, and whether you're telling another software engineer to build it or whether you're telling a system that's actually capable enough to be a software engineer to build it, somebody has to be able to say what it is that needs to be built, right? Differentiation is, so again, with our master's program, we are one of the only universities that is all competency based, and that extends to our master's in computer science program. We are also very much committed to continuing to update and upgrade our AI courses and our other emerging technologies courses, I guess is what I would say. So we are keeping those up to date with our industry standards as we continue to develop and redevelop in a continuous improvement process, right? In addition to those 2 programs, we also have the Bridge program, which is essentially an accelerated program from our undergraduate to our graduate. This Bridge program saves you about a term or between a term and a year, depending on how you're accelerating. But in the Bridge program specifically, several of our courses are replaced, undergraduate courses are replaced with graduate courses. Often these are called swing level courses in brick and mortar universities. So the same idea is that instead of taking the graduate level course, you'll take instead of taking an undergraduate level course, you'll take the graduate level course in replace of that, right? Which reduces your overall time to complete both degrees, which saves you money, right, which is the goal. And in that you will receive the same third-party certifications and undergraduate micro-credentials. And then at the end of your last term of undergraduate work, you'll be able to start into the master's program in any of the 3 tracks. We also have the graduate third-party certifications or certificates in the 2 tracks. Human-computer interaction has the City IRB protocol, and MSCS AIML has the AWS Machine Learning Specialist certificate, right? All right, admissions requirements. So this is something that is unique for the computer science program. We do have some additional admissions requirements within the School of Technology. Really, we want to make sure that students are prepared to get into calculus, right, to start with calculus. So in addition to high school diploma or equivalent, you need to have completed a pre-calculus course from WGU, through WGU Academy generally, or through another third-party provider, right? Or completion of pre-calc or a higher level math course from an accredited university or other academic institution, right? For MSCS, our pathways to admission are to either have graduated with a bachelor's degree in computer science or have a bachelor's degree in another field and complete Foundations of Computer Science at WGU Academy prior to entering. There are many reasons for this, but again, we want students to succeed here, and we want to make sure that you have the appropriate preparation before joining the program fully, right? All right, so I feel like I got through that hopefully quick enough to address some of your questions. Let me go over to Q&A. I know that Joyce, you were typing in there during, so if there are any questions that weren't addressed over there, hopefully
I think there were some questions about like the focus a little bit more, like what we focus on. Somebody had mentioned JavaScript specifically, but I don't think we have anything that focuses directly on that, but they were asking some questions about the focus. If there's different.
So, you were asking if I said Java or JavaScript. So within the computer science standard path, there's a sequence of Java courses that get you that Java micro-credential and backend micro-credential, right? JavaScript, I think, is mentioned in there's one main web dev course in computer science. I think it's mentioned there. It's not like you're using Angular or React or any of these, JavaScript frameworks, right? If that's an area that you're interested in, I would say look at our software engineering track, as it has a separate micro-credential for front end that includes multiple courses that have Java.
So Bruno's asking how many classes they can take. I'm assuming you're talking about the main program. I don't remember how many courses are we at right now. I know we have 117 CUs, but how many courses are there? They're like 32, I think.
30-ish. So the way that WGU works is that you enroll in a program and you have all of the courses in the program available to you with that enrollment. There's no a la carte picking of courses in like an elective model currently. It's all just the standard path, which is in the program guide for each program. So those are the courses that you have to take. And then we do have some single course offerings through WGU Academy. Most of those are used as pathways for students who need something to get into one of our programs fully, right?
Okay, so for the transcripts, it really does vary, but you can actually do self-enrollment if you go onto the website. But I would say it takes probably a good month probably to get through that process, but they might be able to speed that up. Do you know, Matt, if they do that quicker? Sometimes I know that we try to have transcripts in and done by the 15th of the month prior to the new term starting, but they're doing it like all the time.
They're constantly doing it, and it really depends by and large on how many students we have coming in each month. Some months because we have new enrollment every month, some months are heavier than others because, for example, students getting out of high school or who were taking college somewhere else previously and want to switch. So we have heavier months when it's around the enrollment time of other universities. So it really just depends on a month by month load. I do want to hop over to the Q&A section because people have been putting questions in there and I want to make sure that those get addressed.
So Matt, while you do that, I'll go ahead and
Yep.
answer Adrian's question about
Wonderful.
it was about like whether they need that Foundations of Computer Science course. That course is put together specifically for people who are not that don't have a bachelor's degree in computer science specifically, and that program is actually, or that course rather, from the WGU Academy is the place where you would take that, and it just really is a good precursor to what you'd be getting into, just to set you up so that you're really prepared for success in our master's program. And yes, you would need to take that. And we can, if you're doing like a program change or something like that, when your mentor would put that in the system, it would get to me, and then we would talk to you more specifically about planning purposes and how to get through that and everything. So that's just something we do on the side.
Yeah. And so the other thing that, and look at the enrollment guidance on specifics here, but for many WGU Academy courses, if you take that course and then enroll, the money is either refunded as part of the tuition or counts as a payment towards the tuition. I don't know the detail there, so I don't want to make any promises, but we have tried to make it so that we understand that some students will have the experience to be able to very quickly, and this is the whole model, right? Be able to very quickly pass that Foundations of Computer Science course. And so it should hopefully not delay you too much and shouldn't be a financial burden to take it.
Yeah, and I can give you a few more details about that because I deal with the program changes all the time. So if you are a new student coming in, I believe there's a certain time period once you sign up for it and you talk to the academy, they'll go ahead and reimburse you like once you enroll into the program. I believe for program changes that is different, so you would have to ask them if they have anything special for that. But we do have WGU Academy is technically a little bit separate. They're trying to get into our systems a little bit more, but there's some tricks to that, and they definitely have some ways for you to recoup some of your funding for that if you do want to come into it. And you can take that at the same time you are enrolled if you are doing a program change coming into it, because there are some things out there that make it sound like you can't do that, but you actually can if you want to prepare for coming to our program.
So if you already are in a program, please talk to your program mentor. And if they are not sure, they know to reach out to us. And if you are working with an enrollment counselor, they should be able to help you get all of those details. Going into the Q&A section, if I passed AP Calculus AB a few years ago, will that satisfy? I would say that it should, and in fact you would likely get credit for calculus, but that does have to get processed by our transcript team to verify all the details, right? For embedded certifications, licenses, are those able to be taken early? So generally speaking, our standard path is put together for a reason, right? So for example, the Linux LPI, that should generally be taken after you have several other courses worth of experience. And it's not something that I think on its own is going to get you a job, whereas something like IDLE could be taken earlier and could get you a initial job in like basic IT, but it won't necessarily get you the first job in programming. Those will come after several programming courses. That's why we have like the Java and backend certifications, so that depending on your pathway, because you might also be transferring in credit, you might be able to get those ahead of graduation so that you can start using those certifications to apply for positions that are in the area of interest, right? It seems there is assistance from WGU in locating potential internships. We do have several regional partner organizations, like for example, I'm in Ohio, we have WGU Ohio. So regional partners that we work with to locate opportunities for job fairs and things like these regionally. We also have career and professional services that help us locate opportunities where sometimes there's nationally opportunities. And then we have several other mechanisms like Handshake is one that many universities use to try and connect people in like a LinkedIn style, but at that level of trying to find internships and opportunities. And then we also have some simulated internship type things through the Forage, which is free online. If you don't, come here, you can still use them. But those are different types of opportunities that we have. It really depends on your location, what's going to be available to you. How does the capstone group project work with different people working, studying at a different pace? Yeah, so that one is interesting. It's you are able to work asynchronously and submit and get reviews back asynchronously. I would say that this is an area where for the majority of the program, you're able to move as fast as you want through these courses. Your opportunity to take an assessment as soon as you're ready is there. In this case, you definitely want to plan ahead and know that it may take a few days to a week for another student to submit a review to you. And you want to plan ahead as you're reaching that end of the program. Does WGU have hiring partners? In other words, partners with companies with CS students often get hired from. We don't have anything where we have like guaranteed placement currently, but we do have one of the larger living alumni networks. We have 5 to 10,000 students who've been graduating from School of Technology for years now. Not School of Technology. We have more graduates in School of Technology, but in areas of software, right? So we have a large living alumni network, and we have students and alumni who are working in many of the bigger companies. So I would say that no guaranteed placement, but we do see a lot of students place in a lot of those large employers. Full stack option in the near future. If you want full stack, that's essentially available with our software engineering program. You get front end and back end. The only difference between our full stack offering through our certification through WGU Academy is the WADS, which is Web Application Deployment and Support. You get some of those courses in BSWE, you get some of those courses in BSCS, right? But as far as if you're targeting full stack job opportunities, you can absolutely do that through CS, and you would just need to round out your front end skills a little bit while applying. And you can also do that through software engineering, where they have both front end and back end micro credentials.
So we got just about a minute left,
AI,
Matt.
yeah. Let's talk about AI real quick before we end here. So yeah, AI is obviously on a lot of people's minds. There are both opportunities and and lessening opportunities in some areas and gathering opportunities in others. I think that CS is a particularly good area to be in to weather the AI revolution, or whatever you want to call it. And what we're seeing is that folks who understand and can work with and work on AI applications, those job opportunities are going to grow over time. And those who cannot, those job opportunities will diminish over time. I mentioned, Bill Gates recently came out saying software engineers aren't going anywhere. They're still going to be very necessary. The studies show that a lot of the discussions around layoffs due to AI have been a bit mixed. That is it really because of AI, or were the gains what they actually claimed? I would say that generally, no, we are in the adoption bubble of AI. And so people are still figuring out what it's useful for. And if you are in a position to help a company or an organization find uses for AI, that's going to be a good niche to be in. And if you are somebody who doesn't want to work with an AI, programming tool like Cursor, then you're going to struggle to maintain relevancy as more places adopt and accelerate the pace of development, right? I also say that CS is one of the better areas because that's where you get into the physical cross systems, right? AI is not going to hurt your ability to get jobs in robotics. It's going to expand the number of jobs in robotics, right? All right, folks. Well, thank you for sticking with me a little bit afterwards here. Hopefully all of your questions were answered. If not, please work with your enrollment counselors or program mentors. And if they have anything that they're unable to answer, they always reach out to get that information for you. I hope you all have a wonderful rest of your day. Joyce, thank you for joining with me and helping answer so many questions in the chat there.
So thanks, everybody.
Thanks all.